jump right in. So we started with questions like this in our lesson on Thursday. You know, I struggle with days of the week, guys. I never think of whether it's Tuesday or Thursday. So these two triangles, they are similar. Okay, can someone tell me why they are similar to each other? What would the reason be as to why these two triangles are similar? So have a look at them and tell me if you can tell me the reason why these two triangles are similar. Oh, it's very close, Eunice. Bruce. Bruce, can you tell me why these are similar triangles?
Hello, ma'am. Ma'am, because they're both 90-degree angles.
Okay, good. They both have 90-degree angles. That's a great start. What else do they have that they have in common with each other?
Ma'am, all sides are equal.
Are all of our sides equal?
No.
Okay.
Ma'am, that's the only part I can get for now. Sorry.
Okay, no, I like it. It was a very good start though, which is great. Okay, let's chat more about what Bruce has said over there. So Bruce has said that they both have this 90-degree angle. Okay, that's 100% right. They both have this 90-degree angle. It's a great start. Okay. And then we can see though that our sides are not exactly the same as each other. If they were exactly the same as each other, then we'd be saying that these two triangles are congruent to each other. But in similar, we're just saying one is like enlarged or smaller from the other one. Okay. But I'm seeing some great things in the chat here. So Sipo, that's absolutely right. You can see that this angle is the same as that angle. So A is the same as P. And we can see that angle C is the same as angle R. Okay, exactly, Marcus. The only difference is that the one triangle is enlarged, but they have the same angles as each other. So if I'm wanting to say that these two triangles are similar, I'm actually going to write it underneath so that there's a bit more space for you to see. Remember, when we write this, we need to be very careful in the order we write. So I'm going to say triangle ABC. Oh, sorry. Okay, is similar. Remember that symbol over there, that means similar. Okay, to triangle. Now we need to be careful with our order. So A is the same as P, so we're going to write P first. Then B is the same as M, so we're going to write M second. And C is the same as R, so we're going to write R last. Okay, so triangle ABC is similar to triangle PMR, and then our reason is that all of their angles are the same as each other. Naledi, how can I help?
Ma'am, if you got a question asking, is this similar or congruent, how would you know which one is which?
So for congruency, while you're on the line, do you remember what our different cases of congruency were?
Yes, ma'am. It's
okay.
SAS.
Good.
SAA.
SAA, good.
Then, okay, well, sorry, can I just pull up my notes? And then it's RHS.
RHS, good.
And then it's SSS.
Good, okay. So the first thing we would look for, the first thing that's like our easy giveaway, right? Are our sides exactly the same as each other? So do you see how this one over here is 4 and this one over here is 2?
Yes, ma'am.
So those two sides aren't exactly the same. So if our sides aren't exactly the same, then there's no chance that they can be congruent, because congruent triangles mean they are identical in every way, okay? If those sides were the same as each other, then we're going to look and see, do we have one of these 4 conditions? And if we have one of those 4 conditions, we could say that they are congruent, okay? But because these sides are different and all of their angles are the same, we would definitely go with similar.
Okay, so ma'am, are you saying that similar triangles have measurements?
So not always.
Angles.
Not always, but do you see here how AAA is not one of our reasons in congruency?
Yes, ma'am.
Okay, so if we can prove that all of our angles are exactly the same as each other, and there's something to indicate that they are not exactly the same size. So let's say we were given, I'm going to draw something like this. I'm just going to move, guys, don't panic. I will move back to that example now. I just want to draw something over here. Let's say I was given 2 triangles like this. I'm going to draw them so that they look exactly the same. And I'm going to tell you that this is X, this is X, this is Y, this is Y, this is Z, this is Z. Would you say that those two triangles are congruent, or would you say that they are similar right now?
Ma'am, I would say that they are congruent.
Okay, what would your reason be for saying that they are congruent?
Okay, ma'am, now I just got confused.
No, it's okay. I'm trying to trick you. I'm trying to trick you. So it's good that you're really confused. Okay. When we're looking at these triangles, it's very easy for us to think that they are congruent, right? Because they look the same and they have the same angles as each other, right? So we want to think, okay, well, they're congruent because of AAA, because that's the only information they've given us. The only thing they've given us is that they have three angles that are the same. But is AAA a reason for congruency?
No, ma'am, it's for similar.
Yeah. And so in this case, even though they may look congruent, we would not be allowed to say that they are congruent because we actually haven't been given enough information to say that. We would have to go with similar in this case because the only reason we could use is AAA, and AAA it only applies for similarity.
Okay, thank you, ma'am.
Sure. Guys, if that didn't make sense to you, let me know. If you sort of want to follow up on this. Questions are great. Ask as many questions as you like. It's fine if we sort of move along the road a little bit. Don't panic. Okay. So AAA stands for angle, angle, angle. So it's telling us that there are three angles that are the same as each other in both of our triangles. So A is the same as P, B is the same as M, C is the same as R. Those are my three angles that are the same in both triangles. Okay, so if our angles are all the same as each other, it's always going to be similar. It's not going to be congruent. Okay. Oh, don't worry, Kara. We understand. Load shedding's real for everyone. Okay, so the first thing we can see is that they are similar. Cool. That's a great start. The second part of this question is they are wanting the value of X. Who thinks they can tell me what my value of X would be? Yes. Singa, can you tell me what my value of X would be?
Okay, ma'am, this is just me trying.
That's great.
So, yeah. So, since it was 4 in triangle ABC, and then in PMR it was 2, ma'am.
Yeah.
And then it was divided by 2, ma'am, meaning they're also going to
Good.
divide 2, and then it's going to become 4.
Yes, that is 100% right. Good. What we do to the one, we have to do to the other, and so X would be 4. Perfect. 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 Okay. All right. Let's see. Boho, can I help?
Ma'am, your screen is zoomed in again. I can't see.
I've tried to leave space on. It's like literally in the middle of my screen on this side. It's not on this. It's not on the sides. What are you unable to see at the moment?
Well, first of all, I cannot see what you wrote for 8. What you wrote at the top. I only can see 8 centimeters and X, and then I can see the angle of 90 degrees. Yeah, now it's better, ma'am.
Okay, I don't know if I'm going to be able to keep it like this for the whole lesson because it's a tiny, tiny part on my screen then that you'd be able to see, but I will do my best. Okay.
Okay, ma'am.
Okay, so whatever we do to one side, we have to do to the other. And so we said 4 divided by 2, which gave us 2, and 8 divided by 2, which gave us 4. All right, let's try another one. And I would like you to do it entirely by yourselves. Okay, so I want you to look at it. I want you to do it fully by yourself. I want a sentence that looks like this, and then I want my value of X. Okay. So this is your question. Now, you do have to think a little bit about it before you get going. You do have to think a little bit about it. My first question to you before you do anything fancy is, are these triangles similar or are they not similar? So we're going to do like a little vote. So if they are similar or if they are not similar, I would like you to let me know what you think. So in the chat, tell me whether or not you think these are similar or whether you don't think they are similar. Okay. Alvarez is saying no. Caleb, Asandi, Kiara, Jaden, Isabel. Shoo. Got lots of nuts. We got one day. Okay. Similar. Yes. No. Similar. No. Sure, I'm trying to keep up with you guys.
I think now they're just guessing. You're just getting like random whether it's similar or not similar. You're
Oh,
getting like a variety of everything.
I think Tracy might be onto the right track here. Okay. I'm going to close our voting polls.
They had a voting poll, I see.
All right. So am I tricking you? Am I not tricking you? Let's have a look. If we take a calculator and we say that all of our angles in a triangle, you got bamboozled hard last time and you're about to get bamboozled again. If we have a triangle, all of our angles inside that triangle have to equal 180 degrees. So if I'm looking at this triangle over here, if I say 180 minus 115 minus 33, that is going to give me 32 degrees. If I look at this triangle down here, if I say 180 minus 115 minus 32, that is going to give me 33 degrees. And if I have worked out those two angles, what can you see about these two triangles? Tracy saw it coming a mile away. Once we've worked out those angles, they are 100% similar. They are exactly the same. Their angles are the same as each other. You know, I love tricking you. This angle is the same as this one. This angle is the same as this one. And this angle is the same as that one. Okay. And so if they are similar, we can say a sentence. So I want you to try and think about what the order of your letters would be. So try and get that sentence written for your order of letters, get your reason in brackets. And then I also want you to try and find X for me. So I'm asking you to do a lot of things here. The first thing I'd like you to do is to write your sentence. So I'm wanting you to say which triangle is similar to which triangle. I want you to give me my reason, and I want you to solve for X. Oh, Naledi is ready. Let's see. Naledi, do you have my answer for me?
Yes, ma'am.
Okay, tell me what to write.
Triangle DFG is similar to triangle PMT.
Sorry, my pen's just having a little bit of a triangle. Can you say the order again for me? Sorry.
DFG
yeah.
is similar to triangle PMT.
Perfect. What's my reason?
And my reason is going to be AAA.
Beautiful. And my last step is, what is X going to equal?
The value of X is 4.5.
Yes. And how did you get 4.5?
Ma'am, I said 3 divided by, I said 3.6 divided by 3 is going to give me 1.2, sorry. And then
Good.
I said 1.5 times 3, and then it gave me 4.5.
Excellent. Nice. Nice job, Naledi. Good work. The hands that are up, if they were to answer, if you don't mind popping them down for me, if they're for a question, keep them up and I will get through to them now. If you have a question about what you're currently seeing on the board, please let me know. I am here to help. Just put your hand up and we will get to you. Bruce, how can I help?
Ma'am, can I ask if, for an example, you said GFD, ma'am, if you swap the letters around, is it still okay or is it wrong?
No, totally fine. You just would need to have the other order. So like, what order did you say, sweetheart?
Ma'am, I said FGD and I said triangle FGD, and then I said equal to, and then I said MTP.
Perfect.
Okay, thank you, ma'am.
Totally
That's all I
fine.
wanted to ask. Thank
No
you.
problem. Okay, Mamelo, how can I help?
Oh, ma'am, I wanted to ask the same question because I also wrote the same order.
Okay. Well, good. Then we solved both. Okay, cool. I think we've got, oh, sorry. Nicole, how can I help? Oh, you've just got to unmute on your side. So just push the unmute button. There we go. Hi, sweetheart. How can I help?
Can you please explain how we got to 4.5?
Sure.
At the
Absolutely. Yeah. So when we have similar triangles, we have to do the same thing to go from one to the other. So let's look at it this way. Okay. So let's have a look here. How would I have gone from 1,2 to 3,6? Okay. In order to go from 1,2 to 3,6, I would have to multiply that by 3. So 1,2 times 3 is going to give me 3,6. Now, whatever we do to one side, we would have to do to all of our sides because they are in proportion. So let me get a different color so you can see. If I look at my 1.5, okay, and I'm trying to find this guy over here, I would say 1.5 times 3, and that's going to give me 4.5. And so that's telling me what my X value is going to be. I hope that makes sense. I hope so. If it doesn't, let me know. Okay. Brian is coming. I'm actually having a little bit of a worry about one of the things that Brian's brought because I actually think we may have done it before. But 2 of them we definitely haven't. But I think the one we actually have. I'm starting to have like pre-panic. We'll see when we get there. Okay, one more like this, and then we are going to learn how to do a proof. But we may have to jump to Brian before we do a proof. Okay. I want you to think about everything that we've spoken about in a lesson up until this point. Okay. So I want you to think of everything that we've spoken about. Think of all the tricks. Think of all the traps they've tried to put you in. I want you to figure out if these 2 triangles are similar or if they're not similar. So that's your first goal. Let's write a little list over here. First goal is, are they similar? Second goal is I want my sentence. Okay, and what I mean by that is what triangle is similar to the other triangle. If they're not similar, you can just say this triangle is not similar to this triangle. If they are similar, I want a reason. And if they are similar, I want to know what my value of X is. Those are the 3 things I want you to work out. Okay, let's take it step by step. Think about the other things we've spoken about in some of our previous courses. Hint, hint, nudge, nudge. Think about geometry.
That was hint, hint, my peeps.
Trying to have your back here, guys. I don't want you to fall into a trap. Yes, Nicole, that answer is great. It came in as a direct message, but it's 100% right. A Sunday, do we really feel like they're not similar? Are you sure about that answer? Think very carefully. Think about what these dudes mean. Think about what type of triangle it is. And if it's that type of triangle, what does that mean? Think, think, think. Yes, lady, that is an excellent hint. Angles in a triangle have to equal 180 degrees, and you are dealing with two isosceles triangles. Oh my gosh, even coming here with the right reasons. I like it. Taught you so well. Yes, I'm going to break this down a little bit for those of you who are completely struggling and feeling a little bit lost right now. I'm not going to do all of it. At the moment, I'm just going to look at number one. Okay. Let's just look at triangle ABC to start. If that's an isosceles triangle, because of our reason, angles opposite equal sides, this angle, remember, we're going to pretend the little arrows is equal to this one. So if this is 55, then this is 55. And all of our angles in a triangle have to equal 180. So 55 plus 55 is going to give us 110, which means that is going to be 70 degrees. Okay. If we have a look at our triangle on the right, we can see this angle and this angle are the same as each other. Okay. So we would say 180 minus 70, and that's going to give us 110. But we have to divide that 110 by 2 to get our two different angles. And once you've done that, you should be able to see that they are similar. So I've just done the first part for you. So from here, I want you to write your sentence. And then I want you to find your value of x. So the 2 comes because this angle here and this angle here, they are the same as each other. Okay. And so if we're saying 180 minus 70, we're saying that this 110 over here, okay, has to be equal to this angle plus this angle. So if I want to know which is one of them is, we're going to divide it by 2, and then we would get 55. Don't worry, Sunday, don't be hard on yourself. Your brain is also in holiday mode, so it's okay. Okay, so what you should be focusing on now is how we're going to write the similarity sentence. I can see lots of people are going straight to finding x. I'm seeing good answers for x, but just be careful to not skip the step of writing your sentence. Okay, Singa, have you got an answer for me?
I think so, ma'am.
Okay, I'm ready.
Okay, so you're gonna say triangle ABC is similar to triangle DTP.
Perfect.
And then can I do X first and then the reason, ma'am?
Sure.
Yeah. Okay, and then our X is going to be 20.
Good. Can you explain why?
Yes, ma'am, because 4 times 4 is 16, and so 5 times 4 is also 20. And then my reason for all of this, ma'am, is side, side, side.
Side, side, side.
No, ma'am. Wait. Ma'am, is it sides in ma'am, is it sides in proportion?
So we can't use sides in proportion because they haven't given us all 3 sides. So we can only use sides in proportion if they've given us all 3 sides.
So ma'am, I'm right by angle. Your angle, ma'am.
Yes, angle is right. Side, not so much.
Oh, yeah.
Nice job though. Good work. Okay, so guys, I think let's just quickly write a little note to ourselves on the side. This is great though. I hope that everyone's understanding what's going on. I realize there's like writing all over the place at the moment. If you have questions, please feel free. Also take screenshots when you need. We're just going to write a little thing on the right-hand side to try and help make something a little bit clearer. Okay. Don't worry, Sarah. Okay, so we're just going to write something very quickly over here. We're going to write two things. Okay, we can just draw a little line down the middle over here. Okay. First one is when we are dealing with congruency. Okay, so congruency, that's our symbol when we have three lines that are horizontal. Oh, my line is so skewed. Oh, that's killing me. Okay, when we're dealing with congruency, that's a bit better, right? What does congruency mean? Who can give me like a nice easy sentence on what congruency means? Something super simple. Don't overthink it. Something that would be like easy to remember. What does it mean when two triangles are congruent? Yes, great, perfect. Okay, when two things are congruent, they are exactly the same. Okay, so one is exactly the same as the other. Now, if we're trying to say that two triangles are congruent to each other, they have to fill one of four cases of congruency. Okay, we have SAS, SSS, SAA, and RHS. Okay, let's just have a look over here. SAS. If this side is the same as that one, this side is the same as that one, and they've given us an angle. That would be side, angle, side. Side, angle, side. Okay. Side, side, side. There are two triangles, and they have given us that all three sides are the same as each other. That's SSS. SAA, they've given us one side, and they have given us two angles. That's SAA. And RHS, they've given us a right angle, they've given us a hypotenuse, and they've given us a side. Okay, if I have one of those four cases, I can prove that they are congruent. Cool. In similarity, okay, similarity is three lines that are upright. They have the same angles, but they are enlarged or smaller, so they are not the same size. Okay, and for similarity, we only have two cases. Case one is A. Case two is sides in proportion, and you can just say prop. Okay, if we are looking at AAA, they have to tell you that there are three angles that are the same as each other, or you could work out that they are the same as each other. Okay, sides in proportion, if we were using sides in proportion, they would have to give us all three sides. So 2, 2, 3, 4, 4, 6. They've given us three sides here, and they've given us three sides there. We can see that if we multiplied all of our sides by 2, we would get the same as the triangle on the right. So that means our sides are in proportion. Okay, this is like a very, very quick summary of congruency and similarity. So be very careful with which is on which side. We would never, ever, ever use any of those cases if it's similar. Those ones are strictly for congruency. So when we're in similarity, we're only thinking of AAA or sides in proportion.
My pips, this is really nice. Hey, Teacher Jan, this is a like nice notes, get to go kind of like ish thing. So you better take, I see the demo, or you taking notes over there. So to be fast, just grab a screenshot, girl, and you are good to go. But this is nice and summarize my pips. So we will win at these things.
Guys, it just takes practice. Time and practice. We'll all get there. Okay, I'm going to move past this though. So if you want to take a picture, take a picture. Ah, for your classmates, you're being a good friend. I hear Yolanda was saying that she was super hot in Joburg as well. It's like it was warm in Cape Town, but it wasn't like super hot today.
I feel like if we don't get rain in the next like 2 days, I don't know, like even fridges will start melting even if electricity is there. It's so hot.
38 degrees, that's crazy.
Yeah.
Ugh. Yeah, it is. It's definitely windy. Definitely windy. Okay, let's go straight down to Brian and have a quick brain break, and then we will learn how to do a proof. Okay. So the first one that Brian's bringing us is the one that I'm worried that you have seen before. So if you have, you're just going to get it very, very quickly. And I'm sorry about that. And then the second two you definitely haven't seen. So hopefully one of them will trick you up a little bit. For our new people, this is Brian, the brain. He just comes and gives us a little bit of relief halfway through the lesson. If you don't understand what's going on, it's not a problem. It's just something silly to give yourself a little bit of brain space in between the maths. Okay. I also like his shoes. Me too, me too. Can't go wrong with All Stars. Okay. All right. The first one is the one I think you're all going to be able to give me straight away, but here we go. I am looking for this word. Let's see who remembers it. What is my word that I am seeking? Oh, good. Okay, they don't remember you, Linda. I'm safe. Otherwise, I don't know. I like all of a sudden when I was working it out, I felt like it was super familiar.
You remember?
It's definitely not cone. Don't panic. Don't panic. Try and work it out one step at a time. Like, for example, look there to start. Okay. Find out what that number is. And if you can find out what that number is, you can find out what that letter would be. Ah, there we go. Alvarez got there. Alvarez got there.
Done.
Nice. Good. Okay, but you were definitely on the right track there. You're getting there. Okay, let's talk about it. And then I'll give you another one of this on Thursday, and then you'll know what to do. Okay, so if we have a look at this little rectangle I've drawn, you can see 8 times 4 would give me 32. Okay, so then we're going to say, well, 4 is the letter N. Okay, and so that means that this is going to be an N. All right, then we look at our next one. So like, let's look over here. We could say 4 plus 12 is going to give us 16. So then we're going to look at 12, and 12 is an O. So that's going to be an O. And then you could look at either one of these, whichever one you find easier to work with. Okay, but let's look over there. So something times 12 is going to give me 108. So 9 times 12 is going to give me 108, which is a C. And so our word is once. And that's it. That's the whole question. Hopefully we're nice and easy with it now. Awesome. That's lovely, Kira. Okay, let's try another one. Let's try another one. Next one's super easy. I think you're going to get it very quickly. It's a dingbat. So for those of you who don't know what dingbats are, it's just a picture and you have to figure out what the sentence is. Okay, but I think you guys are going to smash this one. Sorry, it's a little bit blurry. I try my best. But you should be able to see it. Yes, Tando, you got that so quickly, man. Bontle, do you have an answer for me?
Yes, ma'am.
What was your answer, Sudas?
Is it standing in line?
It is 100% standing in line. Well done. Standing in line. Nice job. Okay, so for those of you who can't see it, here is the word standing, and it is inside the word line. Clever, right? Standing in line. Yes, the home affairs line is always super, super long. Okay, one last one. It's also a dingbat. It should be nice and quick, hopefully. I think you'll be able to get.
Yeah, my pets are so clever. They're getting
especially
this
after
like
what we've spoken about today. So quickly. Let's see.
let's go, my people. We can do this. Let's see.
Ah, yes, Tristan. Nice.
Well done,
It
my
would
pips.
be a right angle. Nice. Nice job. Yeah, Nicole, how can I help? Oh, I think she was going to answer. Luazi, so it was just saying, like, it was looking, oh, hi, Nicole, there you are.
Isn't it SAS? Something.
Yeah, so I can see why you guys are thinking that, because it's not an angle, and then it's an angle, it's not an angle. But in this case, it was just a right angle. But I can see where your guys' SAS is coming from, and I like it. Yes, Kamachelo, I think you are correct. It would have been better if the tick had been on the left-hand side. Okay, let's jump and do our first similarity proof and see how we go. Okay, this one I've just written up as a little skeleton for you, and then I'm going to talk you through it. Okay. Yeah, there is a lot going on. Yeah. All right. Similarity proof is the same as a congruency proof with its setup. Okay, so what I mean by that is we have our introduction the same way as we had in congruency, where we say this triangle and this triangle. So let's talk about that. Over here, I've got triangle ABE. Okay, so that's this triangle here. And I've got this triangle over here. So I'm going to say, just going to write that out. So triangle ABE and triangle CDE. Okay, so our introduction, we're just talking about which triangles we're working with. Then in our body, we have 3 reasons. Same as congruency, 1, 2, 3. Okay, now in similarity, remember we only have 2 different cases. Either we can prove that all of their angles are the same, or we can prove that their sides are in proportion. Okay, if we have a look here, they haven't given us any sides, which means we have to prove AA. So we have to prove that all 3 of these angles are the same as each other. So let's look at how we would go about that. Okay, good, Sasipo, excellent. Okay, so Sasipo is saying in the chat, this angle over here, so angle A is equal to angle C, and our reason for that is because of alternate angles. So we can say angle A is equal to angle C because of alt angles when AB is parallel to CD. That's our first one. Okay. Second reason, we can say B is equal to D for the exact same reason. Alt angles. AB parallel to CD. Now for the third one, you've got 2 options. Okay. You could say that they are vertically opposite, so that they are the same as each other. But there's actually a nice trick when it comes to similar triangles. Once you have found 2 we can just say that the other one is equal. So we can now just say that angle AEB is equal to angle DEC. And our reason for that would be third angle of triangle. Or depending, so you could say that, or depending on your school, you could say sum of angles in triangle. Okay, so I'm going to keep it as this because it's the one that we spoke about together when we did geometry. So all of this last line is saying is that if two of my angles are the same, then our third one has to be the same because all of our angles have to equal 180 degrees. And so if you have found two angles, you are allowed to use this reason for your third angle all the time. You never have to think about your third angle. You're allowed to just write that reason. Okay. So now we've found our three angles that are the same. Then we can say, therefore, this triangle is similar to this triangle because of A. And that's where we would stop. How do we feel? Give me an idea of how this is feeling in your heads. Okay, that's okay. Ah, good, good. Okay.
I like how each is so very unique. You are different learners who uses different emojis or expression on trying to answer Teacher Jan's question.
I love it. It's good. And if
Yeah,
you're feeling confused, that's 100% fine, guys. So don't panic. And come on, geometry and you will definitely become friends. I'm determined. Okay. So the next one that I've got here, for those of you who are feeling lost, I don't want you to panic. I've still kept the same skeleton as the last one. You don't need to ask for a name change because I know you are. Fine. Yes, Kira, good. Okay, so what I've got over here is I've kept the same skeleton. Okay, I'm going to leave both on the board. So basically, I've written it up in a way for you to follow. Okay, so I'm going to try and help you out a little bit with this, and then I want you to start thinking about it yourself. Okay, so there's my one triangle. Oh, sorry, let me do the big triangle that they've given us first. Okay, so there's our one triangle. And there's our second triangle. Okay, so just looking at this first line, just looking at the introduction, we've got in triangle ABC. What is the second thing I'm going to write on that line? So we're just introducing our triangles. So we know our first triangle is triangle ABC. What is our second triangle? What are we going to call our second triangle? There we go, triangle ADE. Beautiful. Okay. Yeah, you can. Okay, so remember with maths, when we're feeling a little bit overwhelmed, we're just going to look at it step by step. We're going to look at one thing at a time. We have done our intro. Great. Now we're going to move on to the body. We're going to start with the first one. We're just going to look at angle A. What can you tell me about angle A? What is special about angle A? Good. Naledi, what is special about angle A?
Ma'am, it's shared in both the triangles in AD and in ABC.
Perfect, perfect, perfect. Okay, angle A is in both of our triangles. It is the same. Okay, and so we can just say angle A is common. So we've used the word for common when it came to sides, when we looked at congruency, Now we're just looking at it in angles so that it is in both of our triangles. We can say it's common. Okay, that's our first one. Now let's look at B. Okay, so I'm trying to find what this angle here, what B is equal to. Oh, where to? Can you help me find what B is equal to?
Oh, no, sorry, ma'am. But can you please explain number one again, ma'am, please?
Sure, absolutely, absolutely. So when we have two triangles, if you have a look here, my green triangle is inside my yellow triangle. And so this angle, if I was to draw these triangles out, okay, this angle and this angle, they are exactly the same as each other because my green triangle is sitting inside my yellow triangle. And so they have the same angle A. It's the same point, which means it will be the same as each other. So you could say angle A is equal to angle A because it's common, or you could just say angle A is common. And that just means that it's in both triangles. That's all it means when we say it's common. Great. Yes, these answers coming in the chat are perfect. Okay, B is equal to D because they are corresponding to each other. It's our F. It's our F shape. Okay, so B is corresponding to D because of corresponding angles when DE is parallel to BC. Okay, we've done all the hard work now. What is the thing we have to do for our last angle? Think about what we did here. We're allowed to turn our brain off now. Exactly. Whenever we see parallel lines, our brain needs to think of fun every time. Whether we're in geometry or whether we're in congruency or similarity, if we see parallel lines, we think fun. Okay, so for C, we get to kind of turn our brains off a little bit. Bruce, can you help me with C?
No, ma'am, I wanted to ask, what does fun stand for?
Okay, so fun, I'm just going to draw it a little bit on the left here so that I have a little bit more space. Okay, when we see parallel lines, we think of fun. So fun is the F is looking at corresponding. So we think of fun and CIA. So the F, that's corresponding angles. The U, those are co-interior. Okay, sorry, I'm running out of space here. And then the N, that's our N or Z, that's alternate. So whenever we see parallel lines, we look for those three letters. So we can see, are they corresponding angles? Are they co-interior angles? Or are they alternate angles? Okay, so what's coming through in the chat here? Yes, absolutely. You could say that C is the same as E because they are corresponding. But remember, we're allowed to use our trick for our third angle. So once we have two, we're allowed to use the same trick for our third angle every time. And we're allowed to just say sum of angles in triangle. So once we've found two, we can just say this every time. As soon as you have found two reasons, you're allowed to just write that as your third reason every single time. Okay, then we're just going to say, yeah, sorry. No,
I was about to say, I feel like in this class is like those maths done right because of the private chats that I'm receiving. Everybody's like, oh, I wish maths was like this always. I'm just putting it there that this math is done right. That's what you understand.
Well, I'm glad it's helping some people. Okay, so then we're just saying which are similar. So we're going to say triangle ABC is similar to triangle ADE because of A. A Sunday, yes. How can I help?
Oh, ma'am, I wanted to answer, then you just wrote it. So
oh, it's too fast. I'm so sorry.
No problem, ma'am.
There is no F. I'm trying to look at my writing. I'm thinking maybe it's my E that's looking like an F. Are you thinking about the F as in the corresponding F? Maybe that's the F you're talking about. And okay, that F would be here. It's an upside down F. So if you can turn it around, that purple F, that would be your corresponding F. Okay. All right. Do we have any questions about what we are currently seeing? Let me know. Don't panic. We've still got our lesson on Thursday to do more of these, so I don't want you to stress. Would it be wrong if there's no triangle before ADE? Oh, thank you. Yes, it would definitely be wrong. Yes, the F is corresponding. Let me write this a little bit bigger. I was trying to fit it in, but I was, let's put it over here. When we have parallel lines, our brain thinks of fun. And CIA. Okay. F stands for corresponding. U is for co-interior. And N is for alternate. FUN. Okay. If you see a U, yeah, I mean, the thing is, so Tristan, whenever there's parallel lines, you could probably find at least two. You could either find a F and a Z, or a U and a Z, or F, and in this case here, we've also got a U, okay? But we want to use the one that would help us. So in similarity, we're trying to prove that angles are the same as each other. And so because we're trying to prove that they're the same, we wanting to look at the F, because the F is going to show us that they're the same. You want to screenshot the whole thing like this? Does that